It's racing through your solar system right now at roughly 130,000 miles an hour, fast enough to cross the entire continental United States in about 90 seconds, faster than any rocket humans have ever launched, faster than anything bound to our sun could ever move. It's old. Not older than your grandparents old, not older than the pyramids old, possibly older than the sun itself, a frozen wanderer that may have been drifting through the empty dark for 7 billion years, maybe closer to 12, before it ever crossed our path. It's roughly the size of a small mountain, venting gas into a cloud so vast it would dwarf a planet, and metal is boiling off its surface at temperatures that are, by every normal rule of chemistry, far too cold for metal to boil at all. And when the world's most powerful space telescope finally turned its eye toward it, it found something nobody predicted, something that's still being argued over in scientific papers being written this month. This thing is called 3I/Atlas. And stop and sit with that for a second, because everything you're about to hear happened in the last 13 months is still unfolding as you watch this, and touches one of the biggest open questions humanity has. Are we alone? And how much do we actually understand about the galaxy sitting right outside our front door? Before we go further, if you're new here, this channel is all about the biggest, strangest discoveries in space and science, broken down without the jargon, no physics degree required. If that's your kind of thing, hit subscribe, because we're about to go deep into one of the strangest objects ever spotted moving through our solar system. Let's start at the beginning, because the story of how this object was even found is part of what makes it so strange. On July 1st, 2025, a robotic sky survey system called ATLAS, short for the Asteroid Terrestrial Impact Last Alert System, was doing its normal job from a small telescope station in Rio Hurtado, Chile. ATLAS exists for one purpose: scan the sky, night after night, for anything that might threaten Earth. It's not glamorous work, it's planetary defense on autopilot, quietly grinding through thousands of images, most nights finding nothing more exciting than a familiar asteroid on its familiar loop. This was not most nights. The telescope flagged a faint point of light moving in a way that didn't fit. Comets and asteroids that belong to our solar system move in predictable ellipses, bound forever by the sun's gravity, like a ball on a string that never lets go. This object wasn't on a loop. It was on a straight, screaming path, arriving from deep space, swinging past the sun once, and leaving again, never to return. Astronomers call that a hyperbolic trajectory. In plain terms, this thing does not belong to us. It was just passing through, on a one-way ticket through our neighborhood. That discovery made it only the third interstellar object ever confirmed in human history. The first, Oumuamua, was spotted in 2017, a strange, elongated object that came and went so quickly almost nobody got a proper look at it before it was gone. The second, Borisov, showed up in 2019, behaving more like a familiar, if distant, comet. Based on those two, scientists expected 3I/Atlas to follow the same script. A quick visitor, a handful of photos, some basic measurements, then gone. A scientific footnote filed away. It was not a footnote, because almost immediately, something about this comet refused to behave. That's the first turning point, and it started with something as basic as figuring out how old this thing actually is. Every comet that formed alongside our own sun, including the famous Halley's Comet, is capped at about 4.5 billion years old, because that's the age of the entire solar system they were born into. You can't be older than the neighborhood that made you. But 3I/Atlas wasn't born in our neighborhood. Astronomer Matthew Hopkins at the University of Oxford led a team that traced the object's path backward through the galaxy, modeling where it likely came from based on its speed and direction, and the results were staggering. His team calculated that 3I/Atlas is likely more than 7 billion years old, with some follow-up isotope studies later suggesting it could be closer to 10 or even 12 billion years old. All non-interstellar comets, such as Halley's Comet, formed at the same time as our solar system, so they are up to 4.5 billion years old, Hopkins explained. But interstellar visitors have the potential to be far older, and of those known about so far, our statistical method suggests that 3I/Atlas is very likely to be the oldest comet we have ever seen. His colleague, Oxford astrophysicist Chris Lintott, put a number on how confident they were. We think there's a 2/3 chance this comet is older than the solar system. Think about what that actually means. The universe itself is about 13.8 billion years old. If the higher estimates hold up, this chunk of ice and dust may have formed when the cosmos was barely a third of its current age, when the Milky Way was still young, still assembling itself out of gas, dust, and the wreckage of dying first-generation stars. The team believes it likely formed in what's called the galaxy's thick disk, an ancient population of stars sitting well above and below the flat plane where our sun lives, stars that are on average far older than our own. This object has been drifting through interstellar space, utterly alone, for longer than complex life has existed on Earth, and it just happened to drift through our solar system in your lifetime, not the lifetime of your grandchildren, not 100 years from now. Right now, while you're watching this video. That's the kind of cosmic coincidence a scientist might wait an entire career for and never see. But none of that prepared anyone for what came next, because tracking its age was one mystery. Figuring out what it's actually made of turned out to be a much bigger one, and this is where the story really starts to get strange. In August 2025, the James Webb Space Telescope, the most advanced infrared observatory ever built, pointed its instruments at 3I/Atlas for the first time, using an instrument called NIRSPEC to break the light coming off the comet into a detailed chemical spectrum. Scientists expected to see a fairly standard cometary recipe, mostly water ice, with a smaller amount of carbon dioxide, roughly the same balance seen in comets that formed around our own sun. What they found instead was a coma, the glowing cloud of gas and dust surrounding the icy core that was overwhelmingly dominated by carbon dioxide, not a little more than usual. According to the measurements, carbon dioxide made up around 87% of the material boiling off this comet, with water accounting for only about 4%, and the rest mostly carbon monoxide. That is the highest carbon dioxide to water ratio ever measured in any comet anywhere, at any point in the history of comet science. Picture cracking open a can of soda and getting almost pure fizz, with barely a single drop of actual liquid left in the can. That's roughly the kind of imbalance JWST detected, radiating off an object hundreds of millions of miles from Earth. Why should that matter to you? Because that ratio isn't just a curiosity, it's a chemical fingerprint. It tells scientists about the specific conditions, the temperature, the radiation, the exact recipe of ice and gas, present in the distant alien star system where this object was born, billions of years ago, possibly around a star that has long since died. We are, in a very real sense, reading a chemical letter that was mailed from another part of the galaxy, sent before Earth had complex life, quite possibly before Earth existed at all. If you're finding this as strange as we are, hit like and drop a comment telling us which detail is messing with your head the most so far, the age, or what's coming next, because it gets stranger. The next twist came from the ground, not from orbit. The Very Large Telescope in Chile, one of the most sensitive optical instruments ever built, turned its spectrometer on 3I/Atlas and detected something that made astronomers do a genuine double take: glowing nickel vapor drifting off the comet at a distance from the sun where temperatures are nowhere near hot enough to normally vaporize metal. And here's the detail that really threw researchers. They found nickel with no accompanying iron. In our own solar system, when comets release nickel, it almost always shows up paired with iron because that's how the metal tends to be chemically locked into cometary material. Finding nickel completely alone, without a trace of iron nearby, is described by researchers as a genuine conundrum, evidence of some chemical process that has never been directly observed before, possibly involving unusual nickel-carrying compounds capable of vaporizing at much lower temperatures than raw metal ever could. Stop and sit with that for a second. This isn't a comet confirming what scientists already knew. This is a comet actively rewriting a small corner of the textbook on how metal behaves in deep space, live, in real time, while telescopes on the ground and in orbit are watching it happen. And then, just when astronomers thought they'd cataloged every surprise this comet had to offer, it delivered one more, arguably the strangest twist yet. After 3I/Atlas swung around the sun in late October 2025 and began heading back out toward interstellar space, JWST caught it again in December, using a different instrument this time, its mid-infrared spectrometer, MIRI. That observation turned up methane, the first time methane has ever been confirmed in any interstellar object. That alone would be worth a headline, but the details make it genuinely puzzling. Methane ice is even more volatile than carbon dioxide, meaning that if it had been sitting near the comet's surface the entire time, it should have started boiling away early, back when the comet first became active, still far from the sun. Instead, the methane signal grew stronger after perihelion, climbing across two separate observation windows to represent about 13.7% and then 27% of the comet's total water output. Astrophysicist Avi Loeb, who has closely tracked the incoming data, has pointed to that rising, delayed pattern as one of the object's more genuinely unresolved features. Something about this comet's internal structure, perhaps layers of ice sealed beneath an older crust, only now being cracked open by solar heating, is releasing methane on a schedule nobody expected. Why should you care about a delayed methane leak on a comet you'll never see with your bare eyes? Because it means this object's interior isn't simple. It's layered, it's structured. It may be holding pockets of material sealed away, untouched, since a time before our sun ever ignited. Every new gas leaking out of this thing is another sentence in a story written in a language we're only just beginning to translate. Behind every one of those data points is a small army of exhausted, thrilled, anxious human beings, and that part of the story rarely makes the headlines. Telescope time on instruments like JWST and Hubble is booked months, sometimes years, in advance, and yet teams had to scramble to insert emergency observation windows the moment 3I/Atlas was confirmed interstellar, racing the calendar because the comet would only stay visible for a limited stretch before swinging behind the sun and disappearing from view entirely. For weeks around its closest approach to the Sun in late October 2025, Earth-based telescopes couldn't see it at all, it was lost in the Sun's glare, and scientists were left waiting, unable to observe the single most active phase of the comet's entire journey, hoping quietly that the object would survive its closest solar approach intact and reappear on the other side exactly where their orbital calculations predicted. Some researchers even proposed repurposing spacecraft already stationed around Mars and Jupiter, missions never designed for anything like this, just to catch glimpses no ground-based telescope could manage. That's not clean, tidy science with guaranteed outcomes. That's real people making educated guesses under real pressure, watching a door that opened once, briefly, knowing it would close again forever. Which brings us to right now, because this story is still being written. As of this year, 2026, 3I/Atlas has already made its closest approach to Earth, swept past Mars closely enough that orbiting spacecraft there managed to photograph it, and crossed beyond Jupiter's orbit in March, getting one final close encounter with the solar system's largest planet that may have subtly bent its outbound path. Researchers are still combing through the data from that Jupiter region flyby right now, still analyzing new isotope measurements that keep nudging estimates of its age even higher, and JWST scientists have openly described squeezing in what may be the last usable observations before the comet fades permanently beyond the reach of most available instruments. Every week, new papers land on preprint servers, each one chipping away at the mystery, and each one raising a fresh question before the last one is even fully answered. Here's a milestone worth marking exactly, because it's rare to get a precise number attached to something this speculative. Engineers studying whether humanity could actually chase this comet down have calculated the physics of a theoretical rendezvous mission, one that would use a daring maneuver, swinging a spacecraft in dangerously close to the Sun, using the star's own gravity like a slingshot to build up enough speed to catch an object that's already racing away at tens of kilometers per second. Their modeling shows that the single most fuel-efficient possible launch window for such a mission would be the year 2035. That's not vague, and it's not science fiction. That's a specific trajectory calculation sitting in a real research paper describing humanity's first realistic shot at physically sampling material from another star system. No mission like that has ever been attempted by any space agency in the history of spaceflight. If it ever launches, it will be unprecedented in the truest sense of the word. There is simply no precedent for it. Zoom out for a second, because this is bigger than one icy visitor passing through. For almost all of human history, we experience the galaxy as something distant, a backdrop of lights on the ceiling of the night sky, unreachable, abstract, mostly theoretical. 3I/Atlas is a reminder that the galaxy doesn't stay out there, politely at arm's length. It occasionally sends pieces of itself directly through our front yard. This comet formed around a star system that may no longer exist in any recognizable form. It has been carrying, frozen inside it, a record of conditions from an era before Earth, before the Sun, arguably before most of the stars you can see with your own eyes tonight had even switched on. It spent longer alone in the dark than complex life has existed on this planet. And then, for a handful of months, it shared the same small patch of sky as us, close enough for our instruments to reach out and touch it with light, before continuing on, alone again, forever, back into the space between the stars. We still don't know exactly why the methane behaved the way it did. We still don't know exactly what internal structure could produce nickel without any iron alongside it, or why this one object carries so much more carbon dioxide than every other comet ever studied before it. Every answer scientists have managed to pin down so far has opened up at least one more question behind it, and 3I/Atlas is now speeding away, growing fainter by the month, harder and harder to observe, with the clock quietly ticking on how much more we'll ever get to learn from this one specific messenger before it disappears back into the dark for good, questions and all, unresolved. If this story blew your mind even a little, subscribe and hit the notification bell so you don't miss what we cover next, because this field is moving fast, with new findings landing almost monthly. Drop a comment and tell us, do you think humanity should actually try to chase this thing down by 2035, or let it go and save our resources for whatever comes through next? Share this video with the one friend who's going to text you, "Wait, this is real?" the second they see the title. And if you want to go even deeper into the search for what's really out there in the dark between the stars, our next video takes you inside the hunt for the next interstellar visitor, and why scientists think we're about to start finding a lot more of them.